We mentioned the union, we mentioned the intersections, as well we mentioned the set difference, and as well as we mentioned how to find the complement of a set. So this one can be a single question, so because there's more exercise to come. After this, we talk about Venn diagram. Venn diagram. How can we represent all these set that we have been saying? How can we represent them in a Venn diagram? How can we represent in a Venn diagram that is a shape, just like a shape? For example, look at this one. Let's use a Venn diagram. Venn diagram. So if you look at this, let's say we have a set like this. What is the meaning of this one? You know, let's say we have A here, we have B here. We have two sets. Let's say set A and B. Now you can see there is one that come across between the two of them, which means what we have in A and B. Remember, we mentioned intersection. That is the element that appear in the first set and also appear in the second set. That means I can call this one as my A intersection B, right? So now let's see a clear example. That one is straightforward and simple and straightforward. Let's look at this. Let's say we have if A is equal to A, B, C, F. And let's say we have our B to be, let's say B, E, F, G, H. You said we should draw a Venn diagram. Draw a Venn diagram. So yeah, you don't need to confuse yourself. You can even check from the set that what do they have in common? Do you have anything in common? So by the Venn diagram, we can be able to fetch out if they have anything in common. Since we have two sets, because the Venn diagram can be of three, it can be in this form. We are coming to that. It can be in terms of three. So now we have two sets here. I have set A, and as well as we have set B. So this is A, and as well as this is our B. So now, if I check, firstly, what I will do is, did they have anything in common? I will check. So now, if you look at set A, we have A here. There's no A here. So I can write that A inside A. We have B here and also appear in B itself. So that means I can have B here. There is C in A, but there's no C in B. So I can put C here. We have F in A. We also have it in B. So I can put F here. So the element that we have left inside B is G and H. You understand? It can even bring in form of a numbers. They can bring in form of a numbers. So what? In some cases, we can have some number outside. Maybe we are given the universal set, and we discover that all the set that we have in terms of that particular set doesn't appear in any of the two. So we can make use of any numbers outside here. Meaning, maybe the two element does not appear in this both sets. For example, let's say we have, for this particular problem, we say if our set is equal to like A, B, C, D, E, F, G, H, I, and J. Let's say, for example, this is what we have. So assuming if you look at set A and B, there is A. If you look at set A and B, we have A. We can cancel this. There is A, right? We have B, so I'm gone. There is C. There is no D. We have E. There is F. At the same time, we have G. We have H also, but there is no I and J. So these three elements will be included outside the two sets. That means I can have here to be D, I, and J. So this Venn diagram or this problem can also come in form of a word problem. Let's look at the word problem. Let's look at some word problem that involve set theory. They said in a class of 20 students, let's say 13 or 12 are hovering mathematics, while let's say 13 are hovering physics. So how many students are hovering, Roman figure 1, both subject, Roman figure 2, only math, only mathematics, Roman figure 3, only physics. This one is very simple and very easy to even go about it. Now, if you look at the problem, you can see it's common in form of a word problem, but that doesn't matter. Either it's common word problems, you can be able to solve it. Now, if you look at this one here, they said in a class of 20 students, that is the total number of the class is 20, 12 are offering mathematics, while 13 are offering physics. How many students are offering first questions, both subjects, only mathematics and as well as only physics? I will just find it one after the other. Let's give her the data. Now, in a class of how many students? 20 students. So that's the number of the students that we have, which is the universal set, is 20. 12 are offering mathematics. So here I want to use M to represent the number of students that are offering mathematics. Those who are offering maths, they are 12. They said, while 13 are offering physics, those who are offering physics, they use P, they are 13. They now said, how many students are offering both subjects? So let's draw our Venn diagram. So our Venn diagram, the first subject, the second subject. Now we have mathematics as well as we have physics. So their total to the universal set is 20. The number of those who are offering mathematics, that one is 12. The number of those who are offering physics, that one is 13. So now the first question, they said I should find the number of students that are offering both subjects. So meaning it's unknown. So I can use any alphabet. What can we use? Okay, let's use X. Let's say let X be the number of students offering both subjects, because it's unknown offering both subjects. So I want to use X to represent the number of students that are offering both subjects so that I can be able to find out the number of students. So now, if I use X here, so the method is very easy. They need to be perplexed. The method is whatever we use to represent the two of them, I will subtract it from the first set and I will also subtract it from the second set. So now, if you look at the first one is 12, the second one is 13. So that means we are going to have minus X here, and as well as we are going to have minus X here. Even if you use Y or you use Z, whatever you use, you subtract it from the first set as well as you subtract it from the second set. So the next step, you will add all the set that we have in this Venn diagram together and equal them to be 20. That's what we have here. So from here now, you can see the first one we have here is 12, right? Minus X. Second one here we have plus X. What we have here is 13 minus X. Then their total, recall their total is equal to 20. You can see it's straightforward. All we have in the set, we add them together and equal them to their total. That is 12 minus X plus 13 minus X. Everything is equal to 20. So let's add those who have number together. Now 12 plus 13, of course, we are going to have 25. Now minus X plus X. That one is what? That one is 0. So minus X plus X is 0. What we have left is minus X is equal to 20. Now the next step here is to correct the like terms. Correct like term means the number will be at one side, the alphabet will be at one side. How? If I like, I can bring this one to this side. If I like, I can bring this one to this side. Anyhow we like it, but let me make it simpler. This is if I'm bringing this one to this side, or anyhow we do it, you're still going to get the same result. That means here, I can have this one to be minus X is equal to 20. Now, this is 25. If 25 come to this side, it's going to become minus 25, right? So that means here I can have this one to be minus X is equal to 20 minus 25. Of course, we have 5. The minus can cancel minus. Then X is equal to 5. If you don't want to use that method, instead of bringing 25 to this side, you can just come here by saying when we have 25 minus X is equal to 20. So let's call it like that. So that number can come here. That one too can go there. That way we have 25. This is 20. and we have minus 20 is equal to x, meaning we are going to have x is equal to 5. And either you use this first method or you use the second method, you are able to get the same result. So that means the number, you recall that we use x to represent the number of students that are offering both subjects. That means now the number of the student that is offering both mathematics and physics is equal to 5. I hope you are following. So now the second question, they said we should find the number of the students that are offering only maths. That is what we have only in maths. Now, only maths is very simple and straightforward. Only maths, that is, they are offering only mathematics. So now, check the Venn diagram. What do we have there? What we have there is a 12 minus x. That is a 12 minus x. Now, recall we have gotten x to be what? We have gotten our x to be 5, isn't it? Now, substitute value of x, that means I can have this one to be 12 minus 5. So 12 minus 5, we are going to have it to be 7. That means the number of the student that is offering both, that's offering only mathematics is equivalent to 7. Now, the next one, they said only physics. Only physics. I will still follow you the same way because I know that from physics they say that what we have in physics is 13 minus x, right? So if I substitute the values, our x is 5. That means I can have this one to be 13 minus 5. You understand? Because the value of our x is what? The value of our x is 5. So if you substitute the value of our x to be 5 here, that means that we have this one to be 13 minus 5. Then what are we going to have there? So whatever you have here, you write the result. So now you can even check if your answer is right or is wrong. You can check because if you minus here now, I think you are going to have 8. You can verify if your result is right or is wrong. Now, what I have for only mass now, I can check if the equivalent to 20. What I have for only x now, what I have for only mass, we have it to be 7. We got our x to be 5. And we have our only physics to be 8. So let's see if their total is going to be equal to 20. Now, 7 plus 5, that is 12, right? 12 plus 8, we are going to have 20, which means the result is true. So next, let's solve one more problem. There are some situations by which we'll be given a number outside that's not part of that particular two set. That maybe it's outside, just like the way we mentioned earlier in form of a word problem. We can just solve that one. For example, let's say we have, they said in a community of, let's say 20 people, 10 likes ice cream, 8 like let's say 8 like yogurt, or let's do example. Let's say 8 like banana, and 2, or let's say and 7 like none of the two. So how many people likes both ice cream and banana? So if you look at this problem, this is another set of a problem. On that set, we are given is 2 also, is 2, but we are given to be, let's just say, they said in a community of 20 people. That's here too, the number of the people that we have in that community is 20. That's the universal set is equal to 20. 10 like the ice cream. Let's use I to demarcate the number of those who like ice cream. They are 10. 8 like banana. The number of those who like banana, they are 8. And 7 like none of the two. That is, they don't like banana. At the same time, they don't like ice cream. So none of the two. That is first one and the second one, they don't like the none of the two. We have it to be 7. They now said, how many people like both ice cream and banana? So we are trying to find the number of those who like ice cream and banana. So here, the other time we use X. So here, let's use another alphabet. Anyone you use, either you use X, either you use Y, it's still the same thing. So let's write our Venn diagram. First one, we have our Venn diagram like this. The total is 20, the first one and the second one. Is our ice cream. This is a banana. So the number of those who like ice cream, they are 10. So I can put 10 here. I can put 10 here. Now, the number of those who like banana, they are 8. I can put 8 here. Now, the number of those who do not like ice cream and maybe they don't know how to drink the ice cream and at the same time they don't know how to eat banana. So we keep them 7 here. Why is it outside? Because it's none of the two sets. So they now said we should find the number of those who like ice cream and banana. So maybe we should use Y to represent them. If I put Y here. Remember the first step I mentioned earlier? We subtract X of the first one and from the second one. That means I can have this one to be minus Y and minus Y. We add all these values together and equal it to be 20. So that means from the first one we have there is a 10 minus Y plus Y plus 8 minus Y plus together with the one we have outside there, which is a 7. Everything is equal to 20. Then I will keep adding them. 10 plus 8. That's going to give us 18. 18 plus 7. That's going to give us 25. So I can have this one to be 25 minus Y plus Y. Of course, that one is 0. What we have left is minus Y is equal to 20. So just like what we did the other time, we collect the like terms. We are going to have 25. This is plus 20. When it comes, it's going to become minus 20 is equal to Y. So which means Y is equal to 5. That means the number of those who like ice cream or banana is equivalent to what? Is equivalent to 5. So anyhow they bring the set, either 3, either 4, just follow the same pattern, the same process, so that you'll be able to know how to approach a problem concerning what? Concerning sets. So far so good. We mentioned how to find operation, how to perform the basic operations. We made mention of intersection. We made mention of union, the complement and set difference, and at the same time we mentioned how to approach a problem concerning Venn diagram. That's all about set operation that we discussed so far. To get more examples and more exercises, there's a link in the description below that will direct you to our website so that you can get material that we are using for better understanding. So thanks. Remember, all our videos here has been reviewed by Department of Mathematics, Federal University Duse before we post them here. So you can be sure that you are getting the highest quality education possible. So hit the like and subscribe to our channel. Thanks for watching.